Welcome, everyone. We are delighted that you could join us for today's Working Ethics into the Conversation webinar. I'm Rosalyn Berne. Before introducing today's guest speaker and discussant, I'd like to just put out a few process items. The first, you are all on mute and will remain so throughout the entire session. Any communication you wish to have with our speaker will come through only in writing. Please post any questions in the Q&A. That button can be found at the bottom of your screen. We will attempt to acknowledge and read all of your questions and to have them answered, though this cannot be guaranteed. The Online Ethics Center, also known as OEC, is a project of the National Academy of Engineering in partnership with the Center for Biology and Society at Arizona State University and the Illinois Institute of Technology's Center for the Study of Ethics in the Professions. The Working Ethics into the Conversation webinar series is also a collaboration with the Engineering Ethics Division of the American Society for Engineering Education. We thank the National Science Foundation for their support of the OEC. The OEC provides a host of resources for faculty, students, and practitioners of engineering science. It will soon be host to a forum on teaching ethics for STEM faculty new to teaching ethics, wanting to explore, share, and reflect inside the community about ethics instruction in engineering and science. Today's speaker is Dr. Michael Loui, Professor Emeritus of Electrical and Computer Engineering, University of Illinois, Urbana-Champaign, excuse me. Recently retired from the Dale and Susie Gallagher Professorship in Engineering Education at Purdue University. Michael will address the question of what is professional responsibility in engineering. Welcome, Michael, and thank you for kicking off our webinar series. Just press unmute and we'll be able to hear you.
Mute now.
There you go. Here we go. Great. Michael,
oh, there we go. Okay,
yes,
thank you.
you.
Thank you. In this presentation, I'm going to discuss concepts of professionalism and responsibility and role model teaching techniques for those of you who plan to teach ethics. Sometimes I will interrupt my presentation to specifically comment on what I might do in the classroom, then you might do the same.
Thank you. And Michael is joined by discussant Dr. Jeff Brown, Associate Professor of Civil Engineering at Embry-Riddle Aeronautical University. Welcome, Jeff. We are delighted to have you with us today. Please tell our listeners a bit about yourself.
Yeah, for having me here. Like Ross said, my name is Jeff Brown, and I teach in the civil engineering program here at Embry-Riddle. Basically everything from introductory statics courses all the way through graduate level civil structural engineering courses. And one of the other things I've been involved in for the past few years has been developing some coursework related to ethics and sustainability. And so I had the opportunity to attend one of the NAE workshops back in October and got to meet this great group of folks. So I'm really excited to be a part of the conversation today. Thank you.
That's terrific. Thanks to you both. I'm going to stop sharing my screen so that, Michael, you can pull up your PowerPoint.
Can everybody see that?
Yes.
Excellent. So the topics today are on professionalism and professional responsibility, and they would typically occupy 2 50-minute class sessions of an undergraduate course. But we can be much more efficient because Jeff, who will play the role of a student, is a very good student and can answer our questions pretty directly. And I'll try to work some of his answers into my presentation. Okay. So, class, what is engineering? Jeff? There you go.
Great. Right, so I actually spent some time with my students on this question because I don't want them to think that engineering is only solving problems from the back of a book. So what I try to hopefully help my students wrap their minds around is engineering as kind of this transformational process of changing the world. And so you're changing energy, you're changing matter, and you're trying to achieve some kind of desired objective.
Oh, very good. So many students will respond that it has something to do with problem solving, but if we push them, it is, as Jeff says, transform matter and energy into achieving a desired objective. But there's and that's similar to a definition that I like that the ABET, Accreditation Board for Engineering and Technology, used to use. Engineering is the profession in which knowledge of the mathematical and natural sciences gained by study, experience, and practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind, or as we say, benefit of humanity, which is partly why we do the work that we do. And as Jeff said, we're using energy and matter, which is similar to the latter part of the definition there. But I'm going to focus here on engineering as a profession, and that its goal is to benefit humanity. So what are professions? Let's see, let's get some data here. Some occupations that are definitely professions include physicians or medical doctors, lawyers, engineers. Are there others? Can you think of others? Jeff?
Yeah, so just the little phrase that comes to mind, the butcher, the baker, and the candlestick maker. So all of those kind of traditional, maybe not, you don't have to quite go to school for them, but certainly critical parts of our culture and society.
Right. So there are many occupations there. In fact, there are
Absolutely.
occupations that I think of butchers, bakers, and candlestick makers more tradespeople, which is my second set of occupations. Plumbers, sales clerk, fashion model. Tradespeople include plumbers. So are there examples of occupations that are more like physicians, lawyers, and engineers, and examples of occupations that are more like...
Sorry, I got that totally out of order, Michael. I apologize. No, what I was going to say on that front, accountants would be a good example. Gosh, now I'm suddenly drawing a blank.
Certainly accountants, that's similar. Clinical psychologists.
Psychologists.
Good. So we have some more data there. How do the professions, the ones that we consider professions, differ from these other occupations?
Well, I think the connection to higher education is probably one of the main features. Probably when you think of doctors and lawyers and engineers as well, they typically have some sort of commitment to ethics or some sort of social role that elevates their status a little bit.
So there's a reason that they have this commitment to ethics, is that they tend to have clients rather than customers, right? So the lawyers definitely have clients, engineers do services on behalf of clients, whereas sales clerks have customers. So I'll just talk about some of the differences between clients and customers. That clients have a lot at stake when they consult a professional. Customers is really more of a transaction. I like to also say that the customer is always right, but the client might not be. The professionals give the clients what they need, not necessarily what they want. For example, if you go to your doctor, you don't say, just give me a prescription for opioids because I'm an addict. I mean, just because you want it doesn't mean the doctor's going to give it to you. So similarly, so that the physician is not a hired gun who does what the patient wants, nor should the engineer be a hired gun who always does what the client or employer wants. So some of these differences between professions and other occupations are ones that you did mention. We have this education because professionals have this special knowledge and skills that can be gained primarily through higher education, formal education, often through a postgraduate degree, like you would get a Master of Urban Planning or a Master of Social Work or a Doctor of Psychology degree. Nursing and engineering recognize the bachelor's degree as a professional degree. Now, of course, plumbers have specialized knowledge and skills too, but the training of plumbers and electricians, tradespeople is more apprenticeship model, whereas the professions tend to have this more formal education model. Now, as a consequence of the this set of high level of knowledge, and it's professionals exercise judgment when they apply this knowledge. What they do cannot be automated. And furthermore, clients can't evaluate the quality of those professional judgments. In a sense, professionals hold authority. Only other members of the profession can evaluate the quality of the professional work. So that's why it's important to have peer review. And that's definitely a characteristic of all professions. As a consequence, since clients have great values at stake, the professionals need to be trustworthy. All of us need to be trustworthy because we ought to honor our promises and do the work that we're assigned, but professionals have this special need for trustworthiness. And finally, to ensure that the public is not harmed by professionals, there's a variety of social mechanisms and community sanctions. There's accreditation of engineering programs. All of you know about ABET accreditation, and then licensing of individuals. A lawyer has to pass a bar exam to practice law in a state. My wife, a social worker, has a license from the state of Illinois to practice social work. So why are professional licenses? Well, what is a license? What do you think a license is? Jeff?
Sorry, I keep muting myself. Well, it's basically the social contract or the social agreement that says that you have the right, you have the skill set and the training to perform the service that you have the license for.
That's right. It's a formal recognition by society, official permission that you are able to do something. So students would know about a driver's license, for example, at least, and that the driver's license entitles the holder to operate an automobile. So that's a license gives you legal authority and certain privileges that go along with that. So in terms of special privileges of professionals, well, they have the privilege to apply their knowledge and skills and actions that ordinary people cannot do. We allow professionals to do things that we don't allow others to do. If I put a drill into your mouth and tell you open wide, you would not let me do that, but you allow your dentist to do that. I like to say professionalism is the difference between oral surgery and assault. So dentists have the privilege of putting drills into patients' mouths. Physicians can prescribe medications and perform surgery, which you or I probably shouldn't try to do, even though we're doctors. We're not medical doctors. And then engineers design skyscrapers and passenger aircraft, which are, again, actions. So in general, professionals perform actions that are dangerous or risky in the hands of non-professionals, and only licensed engineers can sign off on engineering drawings for these large buildings and large objects such as aircraft. Now, one of my favorite quotations, which is attributed to Voltaire, but appears in the Spider-Man movie, is that with great power comes great responsibility. Since professionals have great power to affect the lives of their clients, professionals must exercise that power with great responsibility. And that brings us to the topic of responsibility. So some responsibilities for professionals. We say that someone is responsible when they have the ability to affect an outcome. So responsibility means you have the ability to affect an outcome, and professionals have these special responsibilities that derive from their special skills and knowledge and the power to apply that expertise. We say that doctors are responsible for the health of their patients. Patients have responsibilities too, but doctors have a special responsibility for applying their expert knowledge appropriately to promote the health of their patients and more generally the human health in society. Engineers are responsible for the safety of the objects and systems that they design. In the Code of Ethics for the National Society of Professional Engineers, it says that engineers shall hold paramount the safety, health, and welfare of the public. So there's a great emphasis on safety in all engineering specialties. Although all of us have an obligation not to endanger other people, that is, we have an obligation, general obligation to avoid endangering others. Engineers have a special responsibility of safety, not only to avoid harm, but also to positively reduce risks of harm through the design of objects and processes. Let me describe these kinds of responsibilities in more detail through a story of the Therac-25 cancer radiation treatment machine. So this was a cancer radiation treatment machine deployed in the 1980s, and overdoses by this machine in the 1980s killed 3 patients and seriously injured 3 others. So we might ask, well, who was responsible here for this disaster? Was it the operator who administered the massive radiation overdoses? Was it the software developers who wrote and tested the control software, which contained several serious errors? Was it the system engineers who neglected to install the backup hardware and safety mechanism that had been used in previous versions of the machine? Or maybe the manufacturer, Atomic Energy of Canada Limited? Maybe government agencies who issued regulations and performed inspections? So there are many players that could be responsible, but they're responsible in different kinds of ways. John Ladd distinguished several different kinds of responsibilities. Causal responsibility, we say something was responsible for an outcome if it caused the outcome. We'd say the tornado was responsible for destroying the village. Also, a failure to act or something that did not happen. The passengers were injured when the airbags failed to deploy, right? So that the failure of the airbags to deploy was caused the injury. In the Therac-25, we'd say the operators administered the radiation overdoses, so they had causal responsibility. Then there's role responsibility or task responsibility when you are assigned a task or when you, by virtue of your position. In the Therac-25 case, the engineers were responsible for designing the device. So that is usually often what we think about in terms of responsibility for something. There's legal responsibility or liability. We would say that probably the manufacturer is somebody, an entity that could be sued in court. And finally, there's this moral responsibility, and professional responsibility is a kind of moral responsibility because unlike the others, it can be shared, right? Whereas if somebody has the role to do something, then others do not. If somebody can be sued, others cannot. If somebody caused it, then others do not. Whereas moral or professional responsibility can be shared. We say many engineers are together responsible, professionally responsible for safety. Also, in addition to being shared, professional responsibility and moral responsibility are more forward-looking, right? They focus on how you can fulfill that responsibility through future actions. In a sense, responsibility is like a virtue. We say somebody's a responsible person. So these kinds of responsibilities and the ones that we want to emphasize to our students are shared and future-oriented. One thing about professional responsibility is not limited to your responsibilities in your workplace. If a hospitalist is on the train and a passenger has a heart attack, then as a medical doctor, the hospitalist is responsible for taking action, even though they're not on the job at the hospital, that the passenger is not their patient. A medical professional is always responsible for health, not just at the workplace. Similarly, a civil engineer who observes unsafe construction practices should take some action, even if it's not their project, because they're always responsible for safety. In addition, responsibility goes beyond compliance with laws and technical standards. One example would be the Citicorp Center in Manhattan that was built in the 1970s, and it complied with all local building codes in New York City. But the structural engineer, Lemaitre, conducted additional tests about winds directed at the corner of the building and determined that it was unsafe. This is normally that's the strongest point of the building, but because of its unusual design with the supports in the sides of the building, as you can see, it had that, it was in fact not safe as built. Another example, in 1989, the Play School Travel Light travel crib was the first commercial portable crib. The testing report stated that it met all applicable standards, but at the time there were no standards for the new product. Eventually, 3 children were killed, and when the top rails collapsed and strangled them. So your professional responsibility for safety in particular goes beyond simply satisfying laws and technical standards. You really need to, or engineers need to think about their responsibilities more broadly. Engineers work in teams, and this often raises questions about who's responsible when you have a whole team or collective responsibility. And But just as in a hospital emergency room, every team member they're all working together toward shared goals, and they're all individually accountable to each other for their individual contributions and the team's products. Each team member may have specific roles or tasks, but the team is collectively responsible for the goals. So even though a former engineering student once told me, always work in teams, that way if something goes wrong, you can blame other people. Responsibility in this sense is not about blame. It's not an excuse to evade responsibility. Right? Taking responsibility means that you take actions to fulfill your responsibility for safety as well as your assigned tasks. Now, professional responsibilities are related to obligations that are stated in codes of ethics. All professions have codes of ethics that describe the specific obligations of members. And these codes do talk about some obvious things like being honest, kind, civil, and so on. But the profession's codes of ethics spell out the special obligations that members of the profession have beyond our ordinary obligations to be honest and fair. So in engineering, we have codes of ethics of varying lengths and purposes. We have the short aspirational code of the American Institute of Chemical Engineers, an educational code for the Association for Computing Machinery, long detailed regulatory codes for the National Society of Professional Engineers. And because they're related to governing boards for licensing bodies, that's why they tend to be more legalistic. And if you haven't seen codes of ethics, I do encourage you to see a variety of them to see what kind of special obligations engineers have. But I'd like to summarize some of them, which is they give us ways of fulfilling our general responsibilities. So sorting out these obligations in relations with clients, engineers should perform technical services competently. All professional codes talk about competence, report data accurately, completely. This is just a matter of honesty. But again, we have a special obligation of honesty because clients are highly dependent on our professional work. In relations with employers, of course, engineers should do the work assigned, but also they should honor intellectual property and more generally, especially with trade secrets, keep proprietary information confidential. All obligations have a confidentiality obligation. Physicians must keep patient data confidential and share only with other health professionals with a legitimate need to know. Engineers should keep proprietary information and trade secrets confidential as well. And then avoiding conflicts of interest. So, as conflicts of interest happen a lot. Why? If I'm an engineer and my brother is a vendor and providing a bid, I can't just order parts from my brother because, even though it's a free country and somebody should profit, why not my brother? But from the viewpoint of other vendors, other engineers, my decision might seem biased, and that would cause a loss of trust. As we said before, it's very important that professionals have this special responsibility to act in a trustworthy manner. In relationships with other professionals, they should provide and accept peer review, mentor junior engineers, that is, senior engineers should mentor younger ones, and this is true in all professions, and then interact collegially. That's a form of respect. That's a very high form of respect of acknowledging other people's work as well. In relationships with the public, besides, of course, the fundamental obligation to ensure the safety of the public, promoting public understanding of technology, and considering the social impacts of our technologies, things like whether new chemical might endanger the environment, or how data mining algorithms might adversely affect individual privacy. So understanding the social impact of technologies, promoting that understanding among the public, and explaining those social impacts when asked. It's a matter of informing the public. Just like when you ask your doctor a general question about human health, they really should do want to share that information with you. But if you want to ask about your own health, you have to make an appointment. So that's often the difference there. The profession as a whole has an obligation to inform the public, and different engineers can take different roles at different times. So now I'm going to step out here. One way I talked for a while, and it's important to have active learning breaks within a long presentation. One of my favorite active learning breaks is the activities is the one sentence summary. and this is one that I have certainly used. Here's in one long sentence, about 50 words, individually define the term engineering professional responsibility, address who, what, and why. And this can take 5 minutes individually. And this is also a classroom assessment. Then I might have the students pair and share. So this becomes a think, pair, share, which you might have heard of. With another student, combine your best ideas into a new sentence. And then cold calling is a basic technique to ensure all students are accountable for these learning activities. After they've had a chance to work with others, they're generally more confident in their answers. So I'll share my one sentence summary here. Engineering professional responsibility encompasses the ethical obligations of engineers in their professional relationships with clients, employers, other engineers, and the public. These obligations include honesty and competence in technical work, confidentiality of proprietary information, collegiality in mentoring and peer review, and above all, the safety and welfare of the public, because engineers' decisions can significantly affect people and the environment. And you can use your students' responses to see just how much and what they've learned. So in summary here, some key points that engineering is a profession, and that like other professionals, engineers should be trustworthy in their relationships with other people, particularly with clients. Engineers have special responsibilities, particularly to ensure the safety of the objects and processes that they design, and that these responsibilities imply specific obligations in relationships with clients, employers, and the public. Now, I also like to conclude my class sessions with a minute paper, and the classic minute paper, in a classic minute paper, which actually takes more like 2 minutes, you ask students to answer 2 questions. What were the most important ideas that you learned in this class session? And what questions do you still have? And it's a kind of a reflective moment. I find it helpful for students to reflect on the lessons of a class session or on the course. And so I'm going to end my formal presentation here with a reflection from a student who took an engineering ethics course with me. Now I understand how broadly engineers can influence society, but with this power comes the ability to do harm as well. The professional engineer, as with all professionals, should consider the implications of their actions, especially with respect to the public. Some of the most interesting and most influential articles we read were the ones that empowered me to be the best engineer I can be. This is not only because my parents influenced me to become an honest and hardworking person, but rather because of the power and responsibility I will have when I graduate. So that concludes the formal part of my presentation. We're going to have a question and answer session here. And if your question is not answered, you're welcome to send me a message to mloui@purdue.edu. You could also send a message to me at my Illinois email address, but I prepared this presentation on a Purdue template because that's what I've been using most recently before my retirement. Anyway, I look forward to a dialogue with you, and particularly with Jeff, and I hope that we can learn some more from each other through a question and answer period here.
Michael, thank you so much. It looks like Jeff has questions, but also we have Derek Coburn has a question. Let's begin with that. And he asks, on the minute papers, do you have them write them down, e.g. in Word, and then submit? Do you discuss them in class? Are they graded?
Okay, so minute papers can be done in writing. Classically, I would hand out a half sheet of paper and then collect those. Nowadays, when students have computers and tablets, they can type something in and then upload it to wherever you're collecting in-class assignments. These are not intended to be graded. In fact, the classic minute paper is anonymous as well, so you really can't grade it. If you do have students submit it with their name, you can at least give them completion credit. I would not grade it for a letter grade or numerical grade, because it's really more information for me as the instructor about what the students have learned. The minute paper was called by Pat Hutchins as a method of gaining a tremendous amount of information for an infinitesimal investment of time. Very helpful to find out what the students learned.
Wonderful, thank you. And I'm going to ask Jeff, you have some questions, and then let the people in the queue know I see you, and we will get to you. Jeff, thank you.
Yeah, thanks. That was really interesting, Michael. I guess one of the questions I have, if I understand correctly, that was the type of information that you would share with students over a two-class
Yes.
Period.
Mhm.
I recently had a similar discussion in my civil engineering profession class, but before that, I asked my students, these are senior civil engineering students, what other courses have you had similar conversations in? What other courses have you specifically addressed this issue of engineering ethics? And I was a little bit surprised at the at the almost non-existent
Mhm.
responses there. And so that's all kind of leading into the question, are there, I'm sure you've thought of ways that engineering faculty might try to infuse this type of discussion across the curriculum a little bit more broadly, as opposed to where you might just expect to see it in a capstone course or something like that.
Right. So as in engineering and life, there are trade-offs between the ethics across the curriculum approach and the putting it in one course just to satisfy ABET, right? The ethics across the curriculum approach was championed by Michael Davis at the Illinois Institute of Technology, or Illinois Tech, where he would show how even a technical problem would be an opportunity for the instructor to talk about the ethical implications. So they might be doing a thermodynamic calculation on a coolant and then discuss the safety of that particular coolant, whether that would be a good choice from a safety point of view, and then move on. The problem with the ethics across the curriculum approach is that it's not obvious to the students that there's an ethical issue or professional issue here. And especially if we don't assign any homework, then students may feel that it's not valued. So the other end, you can, I think, naturally include a module on ethical issues in an appropriate point. Here at Illinois, we allocated 1 week in our sophomore computer engineering course that's usually digital systems and computer design. And we talked about the Therac 25 disaster, and they had some homework to read about that disaster, analyze some cases. We walked through the ACM Code of Ethics. And it's connected with the course because the technical problem is something that the students can understand having taken just that sophomore course. So it seemed like a natural place to put that. So there's no one right way to solve this problem. Different universities make different choices about how much ethics to include. Many colleges and universities have a 1 credit course, 1 semester or 1 quarter in engineering ethics, but it varies quite a bit, from nearly 0 to a 3 credit course.
Okay, thank you.
Thank you, Jeff. We have 2 other questions in the queue, one from Natasha Andrade. Would you be able to share the readings assigned to the students and speak to if the assigned readings focus on micro or macro ethics?
Yes. So the readings assigned to the students, I've taught the course several times, but and I've used different textbooks at different times. So they're not to favor any particular textbook, but there's a variety of textbooks on engineering ethics. And I believe there's a list over in, or you can find some examples of in the online ethics center. For the Therac 25 case, we just have a couple of readings on the Therac 25, which you can also find from the online ethics center. So it's not too hard to find these readings. I'm sorry, what was the other part of the question?
It looks like
oh, macro and micro.
Right.
Yes. Yeah. So I tend to focus on micro ethics because I feel that those are the kinds of issues that students will encounter in their internships, and then when they go into their workplaces. Macro ethics issues are important too. I've done less reading on that. I have fewer materials on that. It's again possible to find those materials, and those are interesting to discuss. For their term papers, in the full 3-credit engineering ethics course, students do tend to choose macro ethical issues because that's what they're interested in. So, but the course that I've constructed tends to focus on microethics. That is, for those who don't know the distinction, microethics are the ethical issues involved with actions of individuals or small groups, whereas macroethics tend to be issues involving the profession or society as a whole.
Thank you. And there are at least 3 or 4 more questions
Go
here.
ahead.
Yes. One is from Jennifer Cole. Do you bring up where engineers do a good, bad job connecting with clients, employers, professionals, and society? I have thought about talking to our students about how engineers often promote technologies like fracking because it is a way to get useful transition fuel, but rarely do they spend the time to talk to the public about the societal impacts. Do you have any suggestions for how to bring up these good, bad examples?
So how to bring up, so I think nudging the students to think broadly about not only the benefits, but also the costs of different technologies in the classroom. And also, I guess, in terms of, I think Jennifer's talking about addressing the public, that's somewhat harder to do for students or even us. I've given only a handful of lectures for the whole public about some ethical issues. I would certainly encourage people to be more, to use whatever opportunities they have to inform the public in whatever forms that they happen to have. I mean, Jeff, if you have an answer too, I mean, please feel free. You have the microphone as well, and I'm not sure I can answer that question very well.
Well, I think one way to maybe approach that too, and as we think about engineering education a little bit more broadly, we don't have a lot of opportunities to really foster discussions about ethical issues in our classes. And so I think that's one of the things that makes ethics a unique topic when it comes to engineering is it really does require students to respond with their own insights and their own, you may as well call them opinions at some point. But I think as much of that type of conversation as we can foster about these ethical issues in the classroom, hopefully that would translate into some sense of, I guess, efficacy in engaging the public a little bit more broadly. I think engineers might leave our programs thinking that they have to know the right answer to answer a particular question or solve a particular problem. Whereas I think a lot of these ethical issues are going to be addressed or resolved within communities through, I guess, more of a dialogue approach. And so maybe helping engineers understand the difference between solving a problem and talking through a problem might be a good way to start on that one.
If I can elaborate on Jeff's response, yes, there are opinions, but ideally these opinions should be grounded in data and reasoning, so that this is an opportunity to introduce critical thinking, the kind of thinking that you might find in a humanities or social science course. And it's entirely relevant to the engineering classroom as well, and the profession, because as professionals, engineers will be dealing with people with different opinions, and being able to be respectful and understand what people's assumptions are, what data they have, what facts they have, and that the engineer's opinion is not always right. Everything's all about trade-offs. So in fracking, for example, there are clear benefits and there are clear harms, and it's important that we be able to articulate both those benefits and harms. And then at some point, there's usually a community or political process that makes a decision. But the engineer plays a really important role by providing that technical expertise. So, and that's why it's very important that engineers, like other professionals, be completely trustworthy.
Very good. Thank you both. I'm going to now dismiss that question and move on. I notice someone has placed a question in the chat room. I will read that, but let me let you all know I'm more likely to see it if you put it in the Q&A. So from the chat room, how would you deal with a student who defies the concept of ethical behavior, i.e. someone who openly says it is acceptable to lie in a professional setting for career advancement?
So sometimes we get those apparently outrageous statements. It's important to take students seriously and so respond in a critical way. Well, why do you say that? What are reasons that favor your position? What are reasons why your position might not be a wise thing to do? And how does it look from the viewpoint of other people? And this actually starts modeling ways in which we talk about ethics. We talk about the different virtues, like honesty as a virtue, or different perspectives, fairness kind of perspectives, how things look to other people. So I think you'll find that the number of situations in which it is acceptable to lie is very small. You usually need really strong reasons to be dishonest. So if you're an undercover spy or something like that, yeah, probably.
Good point. Someone named Jacqueline Huff wrote Dr. Loui, but then there was no further question. So if you're still there and have a question, please submit. I will move on to the next, and that was from our friend Rochelle Hollander, who asks, I would ask about professional responsibility to elicit information and opinion from, say, the public to refine the scope of a project or intervention. So in addition to communication from the professional, there is the question of communication to with the professional.
So I'm sorry, what is the
I'll read that last line again. So in addition to communication from the professional, there is the question of communication to with the professional.
To or with the professional. Mm-hmm. Yeah, that's absolutely right. And engineers in professional practice usually don't have lots of direct communications with communities and people they might be who might be affected by their work. And I think that this is an opportunity for employers, government organizations to provide those kinds of forums where technical professionals can get more inputs from the public. I know that in some areas such as constructing new buildings, you have to have public input and environmental impact statements, but I'm not familiar with how that process works.
Ah, thank you. And from Edward Glore, how can libraries and librarians support working ethics into the conversation? Have the librarians at Granger supported this effort at all?
So Granger, presumably the Granger College of Engineering at the University of Illinois, and there's a Granger Library at the University of Illinois. So we're very proud of that. And our librarians have been very helpful in providing resources. We have a librarian working with the Online Ethics Center, Kelly Loss, is the ethics librarian at the Illinois Institute of Technology. So she's a specialist in that area. And providing resources, helping people find resources. The Online Ethics Center, of course, is a great place to start. And there's Kelly. Kelly, did you want to say a word here? Or if you can be unmuted.
She's unmuted now. Actually, we're unable to hear you, Kelly. You want to try again with the,
there you go.
Okay. I think librarians have been really helpful in terms of helping with publication ethics and data management, and also teaching students about that area. And if people have questions about the Online Ethics Center or you want some resources in terms of teaching, I would absolutely love to help out. My email is las@iit.edu. I'll put that in the chat. Thanks.
Wonderful, wonderful, thank you. So I will dismiss that question and move on to Carol Muller. In engineering, when it comes to ethics, I frequently see concerns and teaching about health and safety. It seems engineers are less likely to address ethical topics in the domain of equity and justice. Mm-hmm. Would you agree? What can be done?
Yes, so you're absolutely right that in terms of the materials that we've developed and our consciousness, that there are engineering ethics instruction tends to focus on safety and health of the public. And I think that those are important goals, but we tend not to think about social justice. There are probably reasons for that, historical lack of materials. There's actually some research on that, and Erin Seck wrote a nice paper on the culture of disengagement and how curricula tend not to address those issues. I'm not sure I have a way of solving that problem, but we do have some materials that have been developed more recently on social justice issues in engineering, and I think there are even conferences and so on. Does anybody else want to answer that question better?
This is Jeff Brown. I can just chime in a little bit. I think one opportunity or one way that we could make some progress in that area would be through what I would call maybe being selective in the case studies that we do choose to look at these ethical scenarios. I mean, I'm just thinking about the Flint water crisis would be an example that comes to my mind. It's very current, it's still happening, but I think that would be the opportunity or the location to engage engineering students with these questions of justice, and they are important.
Thank you, Carol, for that question. We'll move on to a question from Jacqueline Huff. Did right. I am a teaching professor at Penn State and teach intro to engineering design to freshmen. They tend to be overwhelmingly tech positive, and I have been attempting to help them think more critically about technology to at least start some of these conversations that will wade into engineering ethics ideas. It's been difficult. Do you have any questions on how to spark the students to think beyond the technology positive mindset?
Yes, that's certainly prevalent among engineering students, particularly beginning students who are just enamored of all kinds of technologies, and that goes beyond the computing and information technology that I'm most familiar with. I think a good way to capture their attention and realize their dark side is to have examples of disasters or news stories. In the computing technology, we have news stories of data breaches and invasions of privacy. Civil engineering has, actually every engineering discipline has examples of disasters that have occurred. The Therac 25 is a good example. The Hyatt Regency walkway collapse is one I've used with civil engineering students, the Ford Printo disaster. It's nice to have more recent examples of disasters to show that technology is not always beneficial, or at least it has both costs and benefits. And that also gets into the idea, which is part of the engineering mindset, that there are trade-offs.
Yeah.
And one of the things that we're actually looking into right now is, again, I mentioned being selective about the type of story that you use, but the idea of critical narrative, and some examples that we've relied on heavily that seem to work really well with engineering students are episodes of shows like Radiolab. And so I think one of the most powerful or impactful story that I've heard that really does spark a lot of conversation on this front is, how do you solve the problem of Fritz Haber? And so you could probably just Google that one on Radiolab, Fritz Haber, and you've got a 20-minute story that really will spark conversation and get students starting to ask the types of questions that you're talking about.
That's a great example. Thank you for the question. Kelly Arcieri would like to know, have you invited professionals into your classroom to discuss ethical issues they have encountered in their professional life?
So yes, I have. From time to time, it's usually opportunistic when an alumnus or alumna comes to visit, and they can tell stories about what happens in the real world. That helps the students realize that these things are real, that it isn't just professors imposing, forcing them to learn some irrelevant material. And also when students are in internships, they do see problems that occur in the workplace, and I like them to bring those into the classroom as well. So it doesn't just have to be employed professionals, but even students who've been on internships or some who had substantial work experience before.
And I would like to add, for all of you, keep an eye on the Online Ethics Center. We are in the process of talking about the possibility of a podcast series that would feature precisely that, engineers talking about encounters that they've had in their professional lives.
Obviously, there needs to be some sensitivity here. In the classroom, we talk about confidentiality. Our guests have always talked about things that are now public and they're willing to talk about. But you always have to be sensitive to those issues of confidentiality.
Yes, absolutely. And then Carlos Santos, you briefly mentioned the virtue of honesty in addressing students who make or have unethical views towards the profession of engineering. To what degree does a virtue perspective under character education differ from standard ethical education, and should educators approach infusing ethics into their classroom through a virtue perspective?
So there are various ways of approaching ethics. The classic Western approaches are consequentialism, which I translate in costs and benefits, deontological, which is rules-based and looking at duties and so on and rights. But then a virtues approach talks about the personal characteristics of honesty and care and so on. I think that there's merit in all of these. I happen to like the virtues and character approach because that speaks to building one's identity as a professional. And I have published a couple of papers on how engineering ethics instruction can strengthen students' sense of engineering identity. But I'm also kind of ecumenical or pragmatic, and whatever works. It's an engineering value. Sometimes it's easier to analyze something from a virtues perspective, sometimes from cost benefit or duties. So I think it's part of the toolbox. I think it's particularly suited in professional ethics education. People have written articles about this, but yeah, I think it definitely can work. Jeff, do you have a particular approach that you use in your instruction?
Sorry, I think my comment on that one was going to be I do agree with the virtue ethics approach. I probably am not in a position to where I would feel comfortable trying to teach that formally.
Right.
But I think we all, as professional educators, I think that's where we have to lead by example. And if as much as we can live into those virtues and demonstrate those virtues to our students through the professional work that we do, I think that is ultimately going to have the greater benefit than somehow trying to formalize that type of training. But I do agree with the question.
Jeff, to your point, about 30 years ago, Harvard Business School did a study. It came out in a book and it was Can Ethics Be Taught? And what they actually learned is that the most effective method is through the example of virtue, student-professor relationship. It's a really interesting study. Thank you, Carlos, for that. And Ralph Stewart is with us, and he is asking, are there relatively simple opportunities to discuss conflicts between the ethical responsibilities of two different stakeholders in a particular issue? For example, an engineer designing a product and a business person requiring the product design be completed on an unreasonable deadline.
Mm-hmm. Right. So those kinds of cases that pose conflicts between different values do capture students' attention because there's a conflict there. It's a story, and then it invites us to think more deeply. The hard questions of ethics always occur when we're trying to balance two goods. So a product that is functional and that is safe, those are important goods. Being on time or getting to market first there's a benefit to that as well. And so we need to talk through analyze more carefully what are the costs and benefits, who might be affected by any defects. And so these kinds of cases where there are conflicts, and often there are stories, often those are the stories that we remember, are personal stories where there are these conflicts, and then we want to describe how we can take a more analytical stance here and not just say one person wins because they have more power, but reason through them and model that. So yes, I think that anytime you have a real story of something, just bring that in and show what the conflict is.
Great. And then what looks like to be our final question for the hour would be from David Sukup, and he asks, concerning integration of ethics in technical courses, do you see any trends in including ethics cases in technical textbooks? Also, looking at the OEC, is there a sort of ethics cases by typical course titles, for example, fluid mechanics or project management?
So yes, there was an effort a long time ago to develop numerical problems with ethical implications, and those are all archived on the Online Ethics Center. There's a nice supplement by Donna Riley for thermodynamics course that integrates ethics, particularly macroethical issues and justice issues, with a standard engineering thermodynamics course. I don't know whether there's a trend. There are certainly efforts to do that where it's very natural to integrate those ethics cases with the technical course.
Wonderful, wonderful. All right, so what we have is we're at almost the top of the hour with 3 minutes left. If Michael, you can pull down your screen and I will share my screen for our summary.
My screen's already down. So.
Wonderful. Okay. So I'd like to, here we go. Let you know that our next webinar will be on Thursday, the 26th of March at noon. Dr. Rebecca Bates, Professor and Chair of the Department of Integrated Engineering at Minnesota State University, Mankato, will speak on teaching engineering ethics in the context of ABET requirements. She will be joined by discussant Dr. Stephen Starrett, Dean of the School of Engineering and Engineering and Technology Professor of Civil Engineering at Le Tourneau University. Thank you, Dr. Michael Loui and Dr. Jeff Brown, for your participation in today's Working Ethics into the Conversation webinar. And our thanks to all of you who took time to join us today. If you're interested in learning about future webinars or about our OEC forum on teaching ethics soon to come, the best way to stay in touch is by joining the OEC community, and you can do that by logging into onlineethics.org. Goodbye for now.